I'll say this again. All right. So the first point for tonight is to make sure you're familiar with the format for the midterm, since many of you have not taken midterms before in my class. Has anyone taken a quiz with me? And you read over the description, so it will be posted on Canvas. You don't have to come in person, but you can if you want to. And after the 1 hour of the quiz, we're going to give open lab. If you have any questions, that's a good time to come and have those questions answered. We're going to have 25 multiple choice questions, and they will be either concepts or a snippet of code, and then you have to select one of the options as to what is the correct answer. Each question is worth 4 points for a total of 100. And it's open book, but you have time constraints, so you have to be able to complete on time. And just be sure to read the questions carefully, the wording, so in case, it's pretty detail-oriented, you want to make sure to not maybe miss a note in the wording that would actually shift around the entire question, if that makes sense, right? So there may be some so-called trick questions. Any questions or comments? Yes.
So for a midterm, we have the question, and you give us the question, and you give the answer. We choose A, B, C, D, or we have to write it except for some of the code.
That's a good question. It's only going to be multiple choice. So what it means is you have to select one of the options. Any other question?
There are not going to be any questions where you have to choose multiple. Are there? Just one?
Just one. And it's going to cover the chapters through 5. And this is going to include the topic of file I/O, which we'll cover today, but no chapter 6. So you should read everything, including what we talk about today. Question?
Is there a certain time for the quiz?
Yes. It's posted from there, but I'll tell you again, it's from 5 p.m. to 6 p.m. on Thursday, October 27th. So this is this coming Thursday, right? Any other questions, comments? Okay. One of our TAs is out today, so Brian is not here, but John is here. Well, let's talk about file processing. So there are actually 2 topics from chapter 5 I would like us to cover. So as you can see, there was a lot to this chapter. One of them is how to use the Python format function to format your output. And then we're going to talk about how to process files, how to read files, write files to the hard disk, and then have a couple examples to go with. Let's see here. So I posted in week 5, again, chapter 5, but only the topics that we're going to cover today. And before we start talking about specific examples, there was one other thing I wanted to show you. Under Canvas, I have posted a link to a document or a site called PyFormat. So the format function is pretty confusing, and the documentation is not great. And we're just going to do some hands-on examples so that you can see how it works. I think that's easier than to try to explain to you the overarching structure, because it's just really confusing and not well documented. So let's take a look at what might it look like to use the formatting in Python. And this is an additional reference you have here if you like. You don't see the screen. Here is the screen. The PyFormat. One thing to be aware, they're going to post the old and the new syntax. In other words, Python 2x versus 3x. I would not be at all concerned about the old syntax, so just look at the new syntax. And it will give you some examples of how the formatting works. So here is one example of using the format function. Right up here, we use the print function. What we do is we're going to have print out the total value of your changes, and then we want to do some special formatting to the numbers. The way that this is set up is like a template, and then you have the format function applied to the template, and you pass it the value. So this alone probably already sounds, it's not necessarily intuitive to me, maybe it is to you. But the idea being is that you use a template to specify what you're actually changing, apply the format function, and pass in the value. So the general form is going to be a template string. Dot format. I don't know what this is going. And then the values. The template is going to contain the index of the string. So in other words, right now, we have here 150 that gets inserted into the string, and each of these parameters that we want inserted is going to be represented by a zero-based index. The first one is 0, 1, and so on. And instead of continuing to explain, I think the best thing for us to do is to go over a few examples so you can see the output. So please start up your idle editors. Magnifying. I don't know if you want to save this necessarily to a file. We're just going to write some strings and then observe the output. So they will be from the book examples. So you need to make sure to use the quotation marks since they're strings. And then we're going to say hello, space, and then curly braces 0, curly braces 1, comma, you may have $1, $, curly brace 2, and quotation dot format. So there's the function. And then we're going to pass. So we have how many slots here? 3. We see 3 slots. We're going to pass 3 values to the format function. And the first one is going to be Mr. period, separated with a comma. The second one will be Smith, and 1,000, 10,000. So if we print this, what we see happening is that Python is going to substitute the placeholder indexes with the arguments we passed in. And the most simple way in which we can use the format function. Right? you see how the slots here connect with the values we pass? Right? So 0, 1, and 2. Let's do another one. So now we're going to learn of some additional ways to customize the formats. The next one is going to be this int, comma, curly brace, 0, 5, 0, colon 5, comma, was placed in a field of width 5. Dot format 7. So what happened here? Sam was putting for the first curly braces, right? And we have allocated a width of 5 for where this number will be placed. It turns out it only has 1 digit, but we have reserved, so to speak, 5. We have allocated 5 spots for it. And so the 5, we're going to call it format specifier. It's going to specify the format for the value in the slot. Okay. Let's try another one. This int 0, colon 10 was placed in a field of width. What is the width of the field? 10. And I'll make the connections here. And then dot format. And now, as you can see, we have 10 spaces instead of 5. Are you able to print this okay, everyone? It's working? Great. All right, the next one. This float, column, 0, column, 10, dot 5, comma, here's width 10 and precision 5. And then we pass it format, we pass it 3.1415.926. So the 5 here is the precision, which is the number of significant digits that we're printing. So we still have 10, the width is 10, and we have a pi, some kind of pi number here that is with, I don't know, 7 or 8, more than 5, and then we say I wanted to do a precision 5, which made it down to 5, right? So this is the precision. And also note that if we compare here 3, 1, 4, 1, 5, 9, what happened here? Do you see a difference between those two? Besides the fact that they're 5 significant digits?
Oh, it round the
It
number.
rounded up the 5 to 6 because the next digit is 9. So you can't rely on it to be exact. It's going to do some rounding if you use precision point. And that's because it's floating now.
Oh.
So that's something to be aware. Let's try something else now. So we're going to have this boat. Zero 10.5F is fixed at 5 decimal places. And again, 3, 1, 4, 1, 5, 9, 2, 6. Did you see the difference? So what we have done differently is we have added an F to the 5. And what that means is that instead of a precision, we're going to print out as a fixed. And the fixed is going to print 5 without making any rounding up, right? So that's the difference between the precision and the fixed. All right, another one. All right, this float zero, 0.5 as width 0 and precision 5. So the width, you can specify how many spaces you want with the width parameter. You can say I want it to be 10 spaces, and then if your number only has 5, it will actually insert, it will pad without padding. And the other thing you can do is left or right justify, so we'll have an example as well with justification.
It was like 0.5, right? The very last one.
So in this case, the width is 0. What that means is that it will just print, it will not take up more space than what the number is in size. All right. Another one, compare 0 and 0.20. I forgot the closing brace here. Closing quote rather, format 3.14. So if we wanted to have 20 precision points in 3.14, then Python is going to produce that for us, but it's not necessarily accurate, right? Also, I wanted to point out, you probably saw this, but it's worth pointing out that the indexes, they actually go inside what you would call the literal string. So that's a little bit counter to what we talked about, right? We thought the literal string is going to print exactly like you have it. And that's true, except we can put these templates in it, right? I think that's confusing, but you get used to it. Is it, how do you feel about this so far? Is it okay?
Very
It
nice.
makes sense. I think maybe the reason is I find it confusing is because I have learned programming in different languages, and so that's it just doesn't seem like the way formatting is done. But
Would other languages just like concatenate a million times?
well, other languages will pass. They'll call methods that you can call upon with arguments, and then you pass what you want to format as an argument. But this turns out, I guess it's a really good way of doing it because newer versions of other languages are actually adding support for this kind of templating. So again, Python is, the coolest language. Are you okay so far? Okay, so let's add a couple other examples. I guess I'd like to make an announcement about an event. I posted it on the Facebook page. I don't know how many of you saw it. And it is related, I promise. Let's see if I can find it though. Hang on a second here. Meetup, maybe I'll do it. And I'll tell you, you'll see in a moment why I thought about this. How many of you are members of the Seattle Center Web Design and Development Facebook page? Any of you? If you're on Facebook, I encourage you to join because I think it's a good resource. And what I wanted to show you was the following. There is a meetup hosted by Women Who Code, but it's open to everyone in Google. And they're going to have a really amazing, in my opinion, talk about machine learning with TensorFlow. And actually, TensorFlow is represented, uses Python. So it would be great for you because you probably know enough to make sense of it. I don't think you know everything. And it would be a great opportunity for you to learn about machine learning, which is a technique for working with data where you can essentially train your algorithms to process data. There's more to it. So anyhow, if you're interested, so far it looks like there still are spots. You need to RSVP. And it's at Google. They also always provide free food, and even the fact that it's in Google by itself should be good enough reason for you to want to go. And I might see, I will be there, so I might see some of you there too. But it's a great event.
Where is it?
It's on a Saturday though. It's on a Saturday, the 12th, from 9 to 3 or something like that. It's a whole day. If you do want to, if you're serious about going, you should RSVP because those events. I'll try to remember to post a link in the break, so you have it as a reference. All right. And also one other point while I'm going off topic a little bit. I was at some other events at Google last year, and essentially they have these libraries and different functionality, and they are writing them in Python. So they have support for Java, let's say, and then they're rewriting the same library to use Python. So
Is Python newer?
than Java? Well, age-wise, not necessarily, but Python is just getting more and more acceleration and popularity. They were the graphs of the languages, and JavaScript and Java are the most popular language, but the rate of acceleration for Python is really high up. So. Where were we? Python. Okay, let's do a couple other examples here with formatting. All right, so the next one is going to be to show how to use the justification formatting. We're going to say left justification 0 left angle bracket 5 format high and sure enough high is left justified. Let's try this again. Right angle bracket 5 format high. And now, as you can see, we are right justified within the, what is the 5? What is the meaning of the 5? We have allocated 5 spaces for high, and within those 5 spaces, we have right justified. Yeah. And what else? Or we can also center, so it would be centered. Where is this character? I don't use it very much. Where's the character? 6 there. Thank you. 5. Dot format. High. And as you can see, high is in the middle of the 5 spaces we allocated for it. All right. Any questions so far? So we're going to rewrite the change counter program. I don't remember if we did it. Did we do it, John? Yes, wait, great. This is the program where you tell the user, or the user tells I have 5 quarters and 6 dimes and so on, and then it tells you have $4 or $4, $6, right? So it wasn't quite formatted the right way. I'm going to improve it with this new knowledge so that the formatting is the way we expect double digits. So it's not double digits, but rather currency. So 2 decimal spots after the dot. So we don't really want to work with floating points to begin with because they're inaccurate and therefore not ideal for financial operations. So the suggestion that or the approach we can take here is to actually convert the dollars and the cents into integers, and then there will be whole numbers, and then we're going to concatenate them together to create 1.25 total amount. So that's what we are going to do. How are we going to get those values? We're going to use, I would like you actually to tell me the meaning of those 2 operators that we're about to use. Who remembers the double slash? What does it mean?
Forget the name.
Int, not float.
Int division, integer division. And so the double slash means we are going to do division between integers, and the result will be also an integer. And who remembers what the percentage means?
Modulus.
Modulus. And what is it going to give us?
Just the remainder of the division.
It's going to give us the remainder of the division. Thank you, John. And then we're going to print the cents using the array justified with 2 digits, right? And in this case, also the other thing we're going to do is we're going to pad with leading zeros so that if the result is 5 cents, we're going to make it so that it doesn't print 1.5, which would be inaccurate because it will be 150, but rather 1.05. Right? So these are the changes we're going to make to the program here. And instead of looking at it, let's go ahead and code it up together. But now you are aware of the steps we're planning to take, and I don't think it will hurt for us to do it. It's not even very long from scratch. So if you start a new file, save as change to .py. Okay. What is the first thing we need to do? Have comments. So calculate the value of some change in dollars and cents. So we will define our function main. Change counter. What does the slash n do? New line? Is it okay? Okay, great. All right, and then print. Please enter the count of each coin type. So now we create variables. If you're taking the Java class in winter, if I'm teaching it as I think I will be, then we'll be doing this again in Java. So You have to tell me which one you like better. So quarters is equal to int quarters. And now I'm going to assume everyone understands why we have to use the int, or maybe we should say it. Who can remind us why we're using the int here? Geneva?
Because sometimes you have to change the int to a string, vice versa.
In this case, we have to change the string to an int. We want it to be int since we'll be doing math. Or arithmetic with it. Right. Exactly. Okay. Quarters, dimes. Dimes. Equals. Make sure to use the double, close the double parents since we have two opening parents here. You get the syntax error and pennies. So the total is going to equal to quarters times 25 dimes times 10 nickels times 5 pennies times 1. We don't have to say that. And now the line with the formatting. Is everyone clear on the total line here? The line with total, Sue, is this clear?
Yeah.
Great. So let's print the result. The total value of your change is,
So all the quarters get 25, dimes get 10, nickels get 5. Why is it that pennies don't get 100?
what is what to 100, sorry?
The pennies at the end. So quarters is times 25, dimes is times 10, nickels is times 5, and pennies is times 100, right?
No, it's times 1. So it's because it's 1, it's worth 1. Maybe I said 100, but that's why we're not putting anything, because it would be the same as if I'm 1, since it's only 1. Does this make sense? Because we're converting it to the total amount in cents, and then we're going to use the formatting to make it into the dollar dot cents. So, good question, but we should be okay to go like this. All right. The total value of your change is $, and then our first index here, 0 dot 1 0 right angle bracket 2. Format total divided by 1 total. This is getting so the print is going to know that it's one line, so we can break it up like that. Total mod 100. And let's call the main. So let's just test this real quick. So 5 quarters, 4 dimes, 4 nickels, and 5 pennies. $9.30. The formatting looks okay. It looks good rather. So I'd like to make sure that everyone has this working and understands what's going on. So we want leading zeros, right, justified 2 digits, right?
Oh, in the ones place, in the tenth place,
If you have, yeah, in the 10th place, if there is.
and that's with the 0 greater than 2.
Right. And then the second,
Or else it would just be,
so let's make sure we understand. So what is the so the $0, what does this correspond to? What is going to get plugged in there? I want to make sure everyone understands. The total divided by 100 will go here. This is the first index, and then the second index here. And when we ran the program, we saw the formatting. There is a dot in between, so that prints, and then it's going to have a leading 0 if necessary, right? Justified 2 significant digits. Okay. So this is an introduction to formatting and the format function. And again, if you'd like to know more, you can go and try to figure out the Python documentation. And also, as I mentioned, I posted another resource, the PyFormat. Now it's a good time for us to take a break, because when we come back from break, we're going to shift gears and talk about file I/O. So 10-minute break. How's your weekend, Mr. Jonathan?
Good. Not very productive, but that's fine. Well, I shouldn't say that. I listened to a shitwhack of podcasts, which is nice.
I heard about that.
Yeah.
That's awesome.
Yeah. I listened to the first Programming Throwdown.
Oh, you did?
Yeah,
Which
which is just the most recent one, which was expansible websites.
Oh, I haven't listened to this yet.
Yeah, it's well, my first impression, of course, that's off of one listen, is that it is drinking from a fire hose. They do regularly break it down for like they use the phrase 100 level students, right? Like they do break it
The
down.
students, exactly.
Yeah, but I mean, it is definitely like some high-minded ideas, and which I really like being exposed to.
Okay.
But I had like the best laundry trip ever, like listening to Peter Singer. That's his name. Right?
Singer.
Yeah. Seeger.
Peter Singer.
Okay.
No, Singer is a singer. Singer, you're right.
Singer. I think it's
You're
Singer.
correct.
Yeah. Listening to Sam Harris. So the Singer one was just a lot of fun hearing two very smart people disagree. That was very cool.
Yeah.
And that got me hooked. I was like, cool. And these are things I've thought about, but not at all like this. Like, this is very cool. And what you guys really want was shocking and terrifying and awful and really great. And actually kind of like comforting to like hear someone
Here, let's step outside.
yeah.
Recording the lecture, so.
Oh yeah. on record.
Right.
So is every the teach I mean the study is every his example is confined in the textbook.
I think so. Yeah.
Every
Yeah.
example is in the textbook.
Yeah.
Yeah. So yeah, high five. That was incredible.
Okay, so let's see here. So shifting gears to our next topic. So have you ever thought about how files in programs or files rather with information are stored, I should say data instead of information. There is a funny distinction between data and
Yeah.
information that I might not quite get it, but the idea is that information indicates that there's a certain amount of surprise. So there is a surprise to this information. This was somewhere I read somewhere else.
Well,
Yeah, this
a discovery implies some sort of applicable
Right.
thing.
Whereas if it's just the names of people here that we're going to use for usernames, it's more appropriate to call it data rather than information. All right. But what is a file? So we all know that we have used files and we save our files to the hard disk or to secondary memory in order to be able to persist them, right? If we just worked in our program as we work with the shell and then we call it, then what's going to happen? There is nothing left for us saved from our work, right? We need to save them on it's in secondary memory, such as a hard disk or a flash drive, in order for them to be then accessible again. So we can think and define a file as a sequence of data that is stored in secondary memory, such as a disk drive. And as you, I'm sure, are aware, there are many different types of file data types. We can have, tell me, so we can of course come up with text. What other types of data can be stored in files? The student at the very back?
Tables?
Tables? That's okay. That's all right. That's not just text, that's for sure. All right. I don't even know exactly what goes in it's a mix of text and other types. So that's a good one. Any other one?
Numbers.
Numbers? Well, we can represent numbers as text. This is getting a little bit. Okay, so I'll tell you what I had in mind. Something that we can't represent as text, but is very common. What I was thinking about was, how about image files, right? Image files, or maybe binary files. Do you know, like an executable file? If you look at it, have you ever tried to look at the exe file?
Yeah.
Yeah.
Can you see what is inside, Jason? I mean, you can, but you can. It doesn't make human sense, right? How do we distinguish different types of files? If I had a text file versus an image file, the extension is going to give us the difference as far as how we start. All right, and so for this purpose, for the purpose of this class, we're going to focus on text files that are easiest to work with. And it is common that files contain more than one line of text, and they are separated with some kind of what we call a delimiter. In the case of Python, the line of text to the next one is the /n. So that's every line is going to end with \n in the Python language. And a lot of the concepts we talk here and discuss here are going to be applicable for other languages as well. So we're implementing this in Python, but the ideas are bigger than just Python. File I/O is one of the core skills you need to have no matter what language. If you took the class with C# or any other language, you would be going over file I/O. Python is actually quite nice and easy to use. So here is an example of a multi-line string. As you can see here, we have, if we look at the file, or actually not so much look, but the way it's stored in the file, then each of the new lines are going to be represented with the \n, and we have a couple here, and there is a new line. All right, and so those are only going to have effect on printing, but not as far as manipulating, just to be aware as well. All right, so when we work with a file, we are going to need to, the first thing we need to do is we're going to need to associate the file on the hard disk with an object that represents it in memory. Remember how we learned the graphics objects from the graphics library? Well, we also are going to use this notion of an object to represent a file in memory so we can work with it. And then once we have associated a file with an object in memory, then we can manipulate it in the following ways. We can read and essentially read and write from the file. And when I keep on saying file I/O, that's what I'm referring to, input, output, file input and output. And a file is a stream and a resource, so you need to close it as part of your steps for how to work with the file. You need to close it, and when you close it is when actually some bookkeeping takes place and the file on the disk will be updated. If you don't close your file, you might lose your data. The way that this works is interesting. Essentially, every time when you save your file, you're replacing the existing. It might even look like, it might not seem like this to you, but if you have an existing file, the file is deleted and then updated in its entirety with the new file that you saved from memory, right? Does this make sense? All right. And you have to be careful so you don't lose your data. You know that if you haven't saved with Microsoft Word and then your Windows 10 update kicks in or crashes, then you're going to lose your data because it was not saved onto secondary memory. Is everyone aware of when I say secondary memory, what I mean? We talked about this. Could you remind us, please? What is your name?
Stephanie.
Stephanie, could you remind us?
So it's like a hard drive or flash disk storage with access.
Right, it's not accessed immediately, but it's persistently stored. Okay. All right, so how do we read, for example, from a word processor? And the way we're going to do this is similar, but not exactly. With a word processor, such as Word, the file is open, and then the content of the file gets read into the RAM. The file is closed, and then you make some changes, and then what happens is that the changes are actually stored to a copy still in memory rather than on the disk. So this is the difference here. And then if you're saving a word processing file, then the original file is going to be reopened, and then it's going to allow you to write and replace the old content with the new content. Okay, and then copy the version of the document and close the file. How does this differ, and how is it similar to working with text files in Python? So again, the first step is that we need to associate the disk file with an object in Python. And we do this by using the open function. The open function is going to do this work for us. For example, we can have a file with the name infile, and we're going to say open, and then we're going to open a file, let's say numbers.dat. DAT is another file format. You might, I don't know if you're asked to do this, but to be able to see the extensions of your files, that's not related to here, but generally you need to enable it in Windows because it's by default not going to show it to you. So you should really do this if you haven't done it already. So you can see any kind of file extension, right? Okay, so we have a couple arguments though. The first one is the name of the file. And the second argument is going to tell one of two options. Do we want to read from the file or write to the file? And so they are R or W, and you pass a coding argument based on what you want to do. Okay, if you want to read R, if you want to write to a file, W. You can read the entire file. So with the .read, well, after you open the file, you can read it. If you read the entire file, this might really be quite costly in terms of processing. You can also read a line at a time. So read line is going to return the next line up to and including the new line character. So you can get one line at a time. The read lines is going to return the list of the remaining lines in the file. So here is an example of a file. And we're going to still use the print function, by the way. We can just say input, enter the file name, open the file name for reading, read it, and then print. And let's go ahead and start working hands-on here. Okay, so in week 5, in chapter 5, I have a file called names.txt. And we can just work with it. Or we can create our own. Go ahead and download it. Question? Or you can, is there a question? Yeah, or we can just, let's just create one. Well, here's what we'll do. Let's just download it because we'll use it later, but then I'd like you to open it. All right, so let's go back to the, here we go.
It's on the floor. Yeah, and it says chapter 05.
All right, so again, everything is in week 5 module. If you go in week 5, there is a folder called chapter 5. I would like, and you have to be logged in to your Google Drive or you will not be able to download easily. Make sure you download it in Google Drive and then just right click and then download names.txt. And then let's save a couple versions of it so we can play with. I'll copy it to the desktop. Be careful that you don't open it with Word. I guess I don't even know if you have words here, but open it with Notepad, if you would, and then save as.
Do we want to add line breaks?
For now, you can just save as names1.txt.
Do we want to add any line breaks there, or is that?
For this example, it's not. We just print it to a screen, so it doesn't matter.
Okay.
So you should have a named1.txt to work with, and then we're going to, let's go ahead and read this file. Again, it's important you don't open the file with a Word doc or RTF because it's going to add some additional formatting and it's not going to work anymore. All right, so new file, save as, print file.py. Print the file to the screen. Okay, so F name, so we have to get the name of the file, input, enter a file name, and then in file, those are just variable names, so they can be anything, is equal to open, and open is the name of the function again that's going to associate the file on the hard disk with the file with object, representation of it. In file dot read. I don't need this. Sorry. No, the first thing we need to do is say in file comma R. So we want to only read here. And then we're going to call in file read and then print data and call main. I think I have a typo this here. Okay, so a theoretical typo here, there should be the file name. So in other words, we input the file, now we know which file we're working with, and then we open this file. So there was a typo. Try this again. Okay, where did I save this to? Let's see, I think I saved it not in the right place again. Save. You need to save it in the same place as your text file, right? So wherever you put your names1.txt, that's where it needs to go.
Oh, so save that.
Looks like my name is not there. Let's see if I can change. Get out of this magnifier. I moved it. Let's see, where is it? Names one.txt.
I think it's here.
Okay, so here we go. So you have to save the two files in the same place. Now Magnify doesn't work. I'm trying to bring up Magnify. Let's see, try again. Okay, so a couple of things. Your file that printfile.py, it needs to go in the same location as the names one or the text file that you saved, because the reason is that we're not specifying any path to the name, we're just specifying the name. All right, and then after that you can read it and you should get the names. And so the new lines are embedded in the file, but they're not visually available. I'm actually surprised why they didn't show, but they should have shown. So I want to make sure that everyone, maybe I'll let John, if anyone needs help here. Make sure this works for you. Okay. First of all, were you able to run the program? And secondly, does it make sense? What?
Are you in the right class? Did you? Yeah, you are.
So this is the example of reading from a file, and again we have to get the name of the file. When we enter the file name, did you notice we just said the name of the file? So we weren't concerned about the directory structure, and that assumes that the file is in the same place as the program. Normally they would not be in the same place. Well, it just depends. In this case, that's how
Oh,
it
I
works.
see.
Okay, so another minute or two on this example, and then we have some additional examples to consider.
Okay, so we'll save that
Save it.
to wherever you're saving your code as well.
Let's see my notes here. So because we were reading from the file, we used the R argument instead of the W. So I'd like us to do one more example before the end of the class. And this will be the example. Do you remember when we created the usernames from the T-class coming class? We took the first name and last name of a person, and then we put it together to create a username, which was the first initial of the first name and then the 7 characters. Do you remember all this? So let's do the same, but except this time we're going to read the names from the file and then save the usernames in a different file, which will give us the opportunity to both read and learn also how to write to a file. If you write to a file, you have to give it the file name, If the file is not already there, the first time you say write to this file, it will create it. If the file is already there, what do you think will happen? It will just overwrite it, and that's the end of story. So you have to be careful so you don't lose the data that you have saved in the previous file. Okay, let's go ahead and do one more program. And again, this will be the user file. We can still use the same names file. So save your new file in the same location where your text file is for the input. So save as user file.py. Create a file of usernames in batch mode. So if we say in batch, not back, but batch mode, what it means is that we're using files for processing, and that's what it's referring to. All right, let's write our function. Again, I want to make sure that you make sure to put this file, save it in the same location as names.txt. Okay? Are you okay there? Okay. So print, create a file with usernames from a file of names.
Prints after the same as the end.
That's because we could.
I'm just saying, do they act the same as doing backslash then? Of course.
So they're going to put it together. So we can try this. So
No,
if you,
I mean the two prints in the book.
right,
Oh, they'll put it
they'll
together.
just put it together.
I just wanted to be clear. I guess I'll see.
Maybe we should do it so that you can see it.
No, this time. I'm doing it that way.
And then add a comment, get the file names. So in file name. And so note here the case, because first of all, it's case sensitive, so you have to be consistent. And secondly, we're using the first word lowercase, the second word, first letter uppercase is what we call camel case. And this is a programming style that is very popular and preferred in many cases. So you capitalize the first letter of the second or third word in your variable name. Okay? And this is equal to input. What file are the names in? And then output file. What files should the usernames go to? And the next thing we need to do is open the files. You always have to open the files. Like we did before, we associate in file with open in file name. We want to read from the first one. And we want to write to the second one. So output file W. After we open the two files, we need to process the file, the input file. So we're going to get the text from the file one line at a time, but we have multiple lines. So we're going to use a loop. it just makes sense to use a loop so we can process all the lines until we reach the end of the file. So we're familiar with the loop now for line in file. Take first and, sorry, we need to have a hashtag here. Last names from each line, And we can do this with the split function we learned last time, so we can create two variables, first and last. And then we can say line dot split. And split splits by default on which delimiter? On the space. So we are fine like that. Next, we're going to create the username. And that's what we did last time. We want the first name. We want the first letter of the first name, which is index 0, plus the last name. We want the first 7 characters. Okay. So if we say :7, then it's going to give us the first 7 characters. And then one of the other methods from last time, we're going to call lower, which is going to convert all the letters to lowercase so that they're consistent. This is the line that created the username, and then we need to write it to the output file. And it turns out that we can use print for writing to a file as well. So we're printing the username. The difference is we have to print the name of the file. So file equals to out file. And then call the files. In file.close, out file.close, and print. Usernames have been written to out file name. Let's try this out, and I'll bring back the code. So what file are the names in? They should be names.txt. It should go to unames.txt. So I'm just making this file right now. Oh, I have a typo again. Just give me a second here. Out file name is not defined. Let's see here. Output file. So let's make this consistent. This would be out file name. I don't know why I put output. So this should solve it. I think. Okay. Another moment here. Line 12. Out. There we go. Out file name, out file name, out file name. Out file name, where is this not defined?
The first one is out file.
First one.
File.
Okay, there you go. Thank you. I knew that. Okay, and then now let's go and check if we have, in fact, the new file unames. And we do, and what does it have? It has the unames. So it wrote the file, and there it is. And now you know how to read from a file and write for a file in Python. All right?
The file has to exist before.
Well, the file that you're reading has to exist, but the file you're writing does not have to exist because you can create it when you say W. Yeah, sure. Because we are going, the file has 3 lines of names. So each name is separated with a /n, the new line characters. And we want to read it one at a time. We're processing at the line level. We want to create the username for each line on. Does that make sense? You always have the questions. Might get back in. Do you have names of TXT here? No? So your name for TXT?
Were we supposed to change our TXTs?
No. So, have you saved those in different places? Is your file there? Are your both files saved here? You can give it any name you want. So, like I've been saying, you name.txt, but you can name it.
Okay, so yes, we should be able to function
Not TXT.
not to
No, because it's text. So give us names, new names.txt. I think your files are not in the same place. So, let's see. Where's your name.txt?
So what are we supposed to, what should we enter there, Stefan? What should we enter in,
where you going?
where?
Create a file of few names that it's so yeah, it's going to create
What file should we use?
no. The file where the names is this text file.
So that's what I'm asking, should I call it names, but we've done it, which is the one.
No, not
That's
yet.
already here.
There's an error.
On the desktop that you used
Yeah, I have
in the
three.
previous, yeah.
I have 3, so which one is it going?
Actually, on the second question, you create a new file.
Okay, so what file the names in? Okay, so
But
names.
if you just want to download it, yeah, names text.
Well, I can, what do they go into? Which of that? Just create a new one.
Yeah, but you name that, yeah.
Because no one uses conference for it.
Did it work for you?
No. Actually, I see that it created this file, it's in my desktop. It's already
Yeah, right here.
created.
I have this question. You're right. It only took the first name though.
Yeah, but,
Oh, I
it's
see.
stopped.
I'm going to turn off the recording. I think that's. Well, actually, I do have one more example to show you, but I don't know if we have time. Maybe I'll just run this.
Yeah, that's it. Thank you.
Okay, great. I do have one more example to show you, but I think, well, maybe we can do you need more time to work on this example, or would you like to do one more? It is not working for you?
Yeah, so it's not working for you, right?
How is it not working?
Well, the file that the names are in, I put the names does have.
I can definitely help you.
And then I just made up the file.
I don't know what's wrong with this.
Okay.
And it only
What's
said
I
the last
saved it,
name of
I
the
run it,
first name.
I tell it where
So
to
it didn't
go.
iterate.
Okay, so we have a loop line there for line and file, you have that?
And then I just say your names. That
And for he as well. That's,
Sure.
I think that has one.
and it gives me this.
Error. Last name not defined. Where are you using the term
Yeah, well,
last
you spell it
name
wrong.
in your
So
code?
also you name .txt.
No,
Last
no,
name.
no, you need to read
You call it
name
last right here.
.txt is the file that
I also have
contains.
to say last name
No, I
here.
did. I was.
Well, you just have to make a
One
match
to go into.
because that's the first time the computer's heard of last names here.
Oh, okay.
So if you look, it actually went in J Zell from, I want to make sure though it's first, yeah, John Doe, the
so
first one, so it didn't.
tuple
So this
object
is names too.
has no attribute lower.
Okay, so
Okay, so go back to your code.
And I also had thrown error, so maybe I wrote something wrong.
Let me see how I have that written.
I don't know.
you can override it.
Oh, okay.
It's fine to override.
This is
it.
very,
You'll override
very
it.
small,
You should not
but
do
very important. So you have a comma there.
Uh-huh.
What you're doing is creating some different kind of object. It's not a string.
Mm.
I think it's trying to create a list because commas delineate
Yeah.
between list items.
So I don't
You need a
understand
plus
the same problem.
because you're
Oh,
creating
yeah.
a string that's combined.
Does she have a, does she has?
Oh yeah, it's a plus. So now that you have that there, it'll be a string, and strings definitely have the lower function.
All right, I want
So
to
try
just show you something, and maybe you don't have to do it with me, but just take a look here, and then I'll let you work on your program. But I did have one more example that's not exactly in the book.
No, check
to
your
show.
names.
Oh, I know, I'm pretty sure it's there.
I like your optimism.
How do I get there?
Stefan,
Although I just go to the file.
Yeah.
does it work
Your name?
for you?
Open
Do I
it up.
open it?
it's-
Oh wait, no, it's not this one.
Okay.
I'm sure
Then if you know that you have mistakes, then you're on a good
your
track.
names.
All right, I wanted to show you,
I
I'm going
called
to
it your
save
names.
this file as,
We'll revisit that.
so this is sort of optional, so you can watch this and do this with me, or you can ignore me and work on your own, but I'm going to save this as user file dash dialog. And so I'm going to make a couple changes to it. Essentially, what I'd like to do is Python, the Python graphics library allows you to display a sort of a dialog box to ask the user where the file is located so they can navigate to the file instead of having to write it. And this helps with the directory structure and so on. So if you wanted to make it take advantage of this functionality, these are the lines you need to add and change. The first thing is you need to import the library. It's in the library, and then there is a package called file dialog that contains file dialog related functions. So we're importing the package, and then I'm just going to say after it, so we'll import everything in, from import after, right? And now we have access to the functions in this library that will allow us to display the dialog. Now, instead of getting the user to input the names of those files, I'm commenting those lines out. And instead I'm going to say input file name is equal to, and now the name of the function to call. And so again, the function is available from here because I imported this package here. Is going to be ask open file name and then output out file name. Make sure I have my case incorrect or I'll get some errors again. Is equal to ask save as file name. Okay, so I'm rushing a bit here, but hopefully get it to work for the first time. All right, so essentially this is what happened. Did you see what happened? We get this dialog that shows up from the graphics library, and you can ignore it for now. You can close it actually programmatically, but for now, we're going to ignore it. And then it opened a, sorry, let's do this again. It's now asking me on the desktop to navigate to the file that contains the code. So I can select names.txt here. And now it's going to ask me where to save it. So that's my second dialog. And then on the desktop, I'm going to save it as a uname-dialog.txt so that I can demonstrate to you that this file was there. Although I think I might have an error. Let's see. In file name not defined. In file name not defined.
Oh, it's because input file name. We call it
Oh,
in
there
file
we go.
name.
I knew there was something like that. So we're going to change it to in file name and try again. So select the names.txt for my input file, and then select to save as uname-dialog.txt. And now it told me that the usernames have been written to uname dialog. So this worked, and we can verify that the file is there. And it did the same functionality, it worked the same, but you can take advantage of using the file dialog, ask open file, and ask file name instead of just getting the user to enter the file name. So that's more robust, okay? And this was the last example I had to show you for tonight. So now it's going to be open lab, and you can finish up your work and maybe play a little bit with those examples. Does anyone have any questions we want to cover tonight? Geneva?
Actually, I'm just having a little trouble with my program. So
Okay, we can take a look. So let me turn off our recording, and we'll take a look. I guess John's did.
I can't, I don't know how to work in that.